Hello children, I believe you're safe at home. Today we are going to add on what you learned about rhombuses. So that's why we are saying the heading is more about rhombuses. I believe you've done quite enough work on rhombuses. That's our subtopic today. In this subtopic we're going to look at almost everything you learned about a rhombus before. Let's look at the first question. Our first question is the area of a rhombus is 24 square meters if one of the diagonals is 8 meters. Part A, find the length of the second diagonal. If you can recall very well, to get the area of a rhombus, you are given the formula we are supposed to use. So what is going to help us here is that formula. I believe that's what you had last time. I have times diagonal 1 times diagonal 2 is equal to area. That is the formula. Our next step now will be substitution. We substitute what we have, what we don't have, we leave it the way it is. We have the area as 24 square meters. Diagonal 1 is 8 meters. So let's substitute the 2. I believe we shall be able to come up with that. Where we have a half times diagonal 1, which is 8 meters, times diagonal 2, which we don't have. Let's leave it as diagonal 2. The area we have it as 24 square meters. So what can we do from there? Let's look at 8 and 2. We can divide by 2. 2 divided by 2, what do you get? I believe you got that right. We get 1. We divide 8 also by 2. So 8 divided by 2, what do we get? We shall be able to get 4. So now from there we can now proceed. We have 1 times 4 meters times diagonal 2 is equal to 24 square meters. So that will be our next step now. We're having 4 meters times diagonal 2 is equal to 24 square meters. For us to remain with diagonal 2, there's something we need to do now from there. We have to divide both sides by the 4 meters. That we eliminate 4 meters, we remain with the diagonal 2. That's leading us to that next step. So we have 4 meters times diagonal 2 out of 4 meters is equal to 24 square meters divided by 4 meters. So there we have to reduce so that we remain with the diagonal 2 on the left hand side. Sorry. So we divide 4 by 4, we get 1. When we divide also 4 by 4, we shall still be able to get 1. Now something to note there is we are also dividing the meters, the units. So if we took it to be 4 meters divided by 4 meters, we get 1. Then also 4 meters divided by 4 meters will give us 1. Let's go to the right hand side and do the same. 24 and 4 are divisible by 4. So we're going to divide by 4. 4 divided by 4 will give us 1. Then 24, we divide 24 by 4, we shall be able to get 6. Now let's look at our units as well. The numerator will have square meters, denominator will have meters. If we reduce by meters, we shall also be able to get something there. So meters divided by meters will give us meters. Square meters divided by meters will give us meters. So let's look at our answer. Diagonal 2 is equal to 6 meters. That is answering our first question, which says find the length of the second diagonal. we can underline our answer. Diagonal 2 is equal to 6 meters. Let's go to the next question, which reads, calculate its perimeter. Now, when you're talking of perimeter, here we are meaning the total distance round the figure. Total distance round the figure. We know diagonal 1, we also know diagonal 2. So it is very necessary, it's very important for us to sketch this rhombus, and we see how we are going to get it is perimeter. So that is our rhombus. Remember, one of the diagonals is 6 meters, the other is 8 meters. So we have to be very careful here. The longer diagonal is 8 meters, and the shorter diagonal is 3 meters. So looking at it carefully, diagonals bisect each other. So each diagonal we are going to divide by 2. If you look at 8 divided by 2, you shall get 4. 6 divided by 2 will give us 3. So let's look at one of the diagonals. That is the longer one, which is 8 meters. So if we divide 8 meters by 2, if we bisect, we divide by 2, we shall be able to get 4 meters. From the vertex to the center, and from the center to the other vertex. Remember, 4 meters plus 4 meters will give us back our diagonal, which is 8 meters. Second diagonal, which is shorter, was 6 meters, which we calculated for in part A. So 6 meters divided by 2 shall give us, that will give us the 3 meters. They bisect each other. Now, why are we doing this? For us to find the perimeter of our rhombus, there is need for us to get the length of each side of the rhombus. So looking at what we now have, we need to pick out one right-angled triangle from our rhombus. And then from there, we shall be able to apply Pythagoras theorem to help us get the length of each side. So if we pick one right-angled triangle from our rhombus, I believe we shall be able to come up with that right-angled triangle, which has the 2 short sides. One is 4 meters, the other one is 3 meters. So the longer side is giving us the length of each side. We don't know what it is, but we are going to calculate. With the help of Pythagoras theorem, someone remind us our Pythagoras theorem? I believe you must have got something like that. That is c squared is equal to a squared plus b squared. So in this Pythagoras theorem, we need to substitute. Remember, C stands for the longest side, which we can also call the hypotenuse. So looking at our right-angled triangle, the longest side is not given. The 2 short ones will have 4 meters and 3 meters. So C, we don't have C, the hypotenuse, but we have A and B. So let us substitute. Let us replace. Shall come up with that. C squared is equal to 3 meters squared plus 4 meters squared. You need to look at the position of the brackets very well, because now the square is for both 3 and the meters, and also for the second set of brackets, the square is for both the 4 and the meters. So we need to now work out. 3 meters squared means 3 meters times 3 meters. What do we get? 4 meters squared means 4 meters times 4 meters. What will that give us? I believe you must have got what you are now seeing. C squared is equal to 9 square meters plus 16 square meters. We need to add now the 9 square meters plus 16 square meters. What do we get? I believe you've got what I've also got. So C squared is equal to 25 square meters. We are looking for the value of C. So what should we do when we reach there? We need to find the square root of both sides. find the square root of both sides. So we have square root of c squared is equal to square root of 25 square meters. What you do on the left hand side must be done on the right hand side. So help me out now here. What is the square root of c squared? And what is the square root of 25 square meters? Square root of c squared will be c. The square root of 25 is 5. The number you multiply by itself to give us 25. That is 5. 5 times 5 will give us 25. Now the square root of square meters is meters, of course. But remember, our question was clear. Calculate its perimeter. We are supposed to get the length around the figure. So we have found out now that each side of our rhombus is 5 meters. So we can now get our perimeter. Someone remind us the formula. To find the perimeter of a rhombus is equal to 4s. Side plus side plus side plus side. You have 4 equal sides. That's what's going to help us find the perimeter. So 4s means 4 times s. We're going to multiply each side by 4. Our rhombus has 4 equal sides. So we shall now have our perimeter as being equal to 4 times the value of s. Each side is 5 meters. 4 times 5 meters, what do we get? That should be able to give us that perimeter. Our perimeter now of the rhombus is 20 meters. You can underline our answer there. We have got that. Let's look at another example. Let's go to example 2 now. Our example 2 is clearly there. It states the area of the figure below is 384 square centimeters. Use it to answer questions that follow. So our rhombus is clearly drawn there. Diagonal SC is given from A to the center is 12 centimeters. From the center to C is 12 centimeters. So that should be able to guide you to find the length of the diagonal. 12 plus 12 is 24. We are also given the length of each side. You can see DC is 20 centimeters. That's the length of each side. Part A. Work out the length of diagonal BD. Work out the length of diagonal BD. Is the one we do not have. Remember, we have diagonal 1, which is SC, 12 plus 12 centimeters, giving us 24 centimeters. We are given the area, which is 384 square centimeters. We begin with the formula for finding the area of a rhombus. I believe that's the formula. Next step is substitution. We need to substitute this. We have diagonal 1. Someone remind us, which is 24 centimeters. The area is given, so let's substitute that. I believe we shall come up with that. So we have a half times 24 centimeters times diagonal 2 is equal to 384 square centimeters. We have even numbers there, so we can reduce by 2. Look at 2 and then 24. They are divisible by 2. So 2 divided by 2, what do we get? 1. Then we also divide 24 by 2, which will give us 12. So now from there we can now proceed. We have 1 times 12 centimeters times D2 to give us the area. So that will be able to give us that. We have now 12 centimeters times diagonal 2 is equal to 384 square centimeters. We need to remain with D2, which we are looking for, the length of the diagonal. There we need to divide both sides by 12 centimeters. So we shall have 12 centimeters times diagonal 2 out of 12 centimeters is equal to 384 square centimeters divided by 12 centimeters. What are we going to get? We shall now look at the right hand side. We can divide by 12. So 12 divided by 12, we shall get 1. Then 12 divided by 12 will give us 1. But as I told you earlier on, this constant can also combine also the units. So even if I say 12 centimeters divided by 12 centimeters, we shall be able to get 1. 12 centimeters divided by 12 centimeters, we still get 1. So now we are remaining with the diagonal 2 on the left hand side. Let's go to the right hand side. We need to reduce also. This time we are going to be very quick. What's the factor we can use there? There are quite many. You can use 2, you can use 4, and others. But let's go direct to 12. Let's divide by 12. 12 centimeters divided by 12 centimeters. What do we get? We're able to get 1. Now, 384 square centimeters divided by 12 centimeters. What shall we get? We shall be able to get 34. I know some people are going to take some time there, but that's the answer. You can check it slowly. Okay, now let's look at the units. In the denominator, we have centimeters. The numerator, we have square centimeters. So if you reduce that, what shall we get? Square centimeters, if you divide by centimeters, we shall only remain with centimeters. Is that right? So let's see what our diagonal 2 will be. Diagonal 2 is equal to 32 meters. That was a mistake. We put there meters, but that was not correct. So we can adjust that, and we have our centimeters included. We are sorry for that. We are sorry for that. So we can see our steps going through again, the steps, and we're able to see what we are having there. Now, diagonal BD, which our question was asking, is equal to 32 centimeters. I believe you've been able to follow that. Now, if we have part A, we seem to be having part B as well. Let's proceed and look at part B of question 2. It states, find the total distance around the figure. Now, looking at this question, total distance around the figure, one word for that is the perimeter. So we need to find the perimeter of our rhombus. We already have a sketch in part A, we don't need a sketch here. So we have the length of diagonal 1, we also have the length of diagonal 2. And this time, we were lucky that we were given the length of each side. So we shall just go direct to the formula. The length of each side of our rhombus was given as, what he calls, okay. We were given a length of each side of the rhombus as 20 centimeters. So 4s, the same as saying 4 times s. 4 equal sides. So 4 times 20 centimeters will give us 80 centimeters as the perimeter. I think that question is answered. Let's look at our final example. That one there. The diagram below is a rhombus whose perimeter is 40 decimeters. Diagonal SQ is equal to 16 decimeters. Find the length of each side of the rhombus. And the rhombus is there. This time we are not given area. You have to be very careful. We are given the perimeter. The perimeter of the rhombus. Okay? So you can see up there, we have the formula of finding the perimeter, so you have to look at that. Don't forget that. This time we don't have the area. So find the length of each side of the rhombus. So we are just going to now use the formula for finding the perimeter of the rhombus to answer that question. Our formula is right there. Now I have interchanged it a little bit. I've begun with 4s is equal to perimeter. Mark you, this is 4s because all the sides are equal. The 4 sides are equal. That's why I'm using it like that. Substitution. We don't know what s is, each side is, or we know the perimeter. We've been given as 40 decimeters. So now substitution, we shall have 4s is equal to 40 decimeters. Remember, looking for the value of s. So what do we do when we reach there? Between 4 and s, we have multiplication. So the opposite of multiplication is division. So we divide both sides by 4. 4s divided by 4 is equal to 40 decimeters divided by 4. So let's begin on the right hand side. Sorry, the left hand side. We need to divide by 4. 4 divided by 4 shall get 1. 4 divided by 4 shall get 1. Let's go to the right hand side. 40 and 4 are also divisible by 4. So 4 divided by 4, you get 1. How many groups of 4 are in 40? Let's divide and see. 40 divided by 4, you are getting 10. So there are 10 groups of 4 in 40. Final answer. Our side is equal to 10 decimeters. Mark the units. This time we're using decimeters. Let's go to the next question. That's part B. Work out its area. We need to find the area of the rhombus. So to find the area, we have one diagonal which is missing. That's diagonal PR. So we need to look for that diagonal first. To look for that diagonal, what do you think we're going to use? We are still going to use our Pythagoras theorem to help us there. Now the diagonal we have, you have only one. We have the length of each side. It was given in the diagram. So let's substitute. We shall then have A is 8 decimeters squared plus B, which we don't know. The length of each side, the hypotenuse, was given as 10 decimeters. So to substitute will give us 10 decimeters squared. Now we need to work out there. 8 decimeters times 8 decimeters, what shall we get? Then 10 decimeters times 10 decimeters, what shall we get? If you did the right work, I believe you should be able to have what I'm having. So now we have 64 square decimeters plus B squared is equal to 100 square decimeters. Now there, we need to collect like terms. We need to collect like terms. So for us to collect like terms, I believe we shall be able to come up with 64 square decimeters minus 64 square decimeters plus B squared is equal to 100 square decimeters minus 64 square decimeters. When now we subtract correctly, we shall be able to come with that. B squared is equal to 34 square decimeters. Find the square root of both sides. 100 square decimeters minus 64 square decimeters is giving us 36 square decimeters. So to proceed from there, we need to get the square root of both sides. We need the square root of B squared and the square root of 36 square decimeters. Well, first this time, I believe you have done enough of this. Square root of B squared is B. Square root of 36, should be able to know that. And then the square root of D of square decimeters. Square root of B squared is B. Square root of 36 is 6. Square root of square decimeters will just be decimeters. So that one is just going to give us part of our diagonal PR. Now we are looking for the length of the whole diagonal, that is diagonal PR. So we shall now look for it. Our diagonal PR is twice the value of B. So that B you're seeing there is only from the vertex to the center. So we need to again add another one which moves from the center up to where R is. So we shall have 6 decimeters plus 6 decimeters. When we add that, we shall be able to get 12 decimeters. That's diagonal PR. So now which means we have our two diagonals. The first diagonal was given in the diagram. Now here we're looking for second diagonal. We can now get the area of the rhombus, which our question is asking for. So you need to get used to such questions whereby they ask something else, but you need to know what should we start with to be able to give you the answer. So let's go ahead and find our area. I'm just underlining our answer now. Let's go ahead and find the area. The area of the rhombus now is what we want to get. The formula is area is equal to diagonal half times diagonal 1 times diagonal 2. We substitute, which gives us a half times diagonal 1 is 12 decimeters times diagonal 2, which is 16 decimeters. From there we can cancel by 2 because we have even numbers. So 2 divided by 2, we shall get 1. Then we are looking at the 2. If we cancelled 12 by 2, we shall get 6. Multiplying 6 times 16, that will be that option. Let's look at the other one. If we cancel 16, that means we shall be multiplying 12 by 8. Of the two, which one is easy? I believe the second option is easy. So let's divide 16 by 2, which will give us 8. So our next step now will be multiplying 12 decimeters times 8 decimeters. If we multiply that very fast, to be able to give us our answer as 96 square decimeters. So we are there underlining our answer. So that's our answers. Thank you very much for listening. I've been Mr. Okore Jacob. I wish you the best. Download the activity after this video. Thank you so much.